welcome to the Vitess Deep Dive. My name is Dan Kozlowski. I am the Minister of Engineering at PlanetScale. Also giving this talk is Sugu Sougoumarane, the CTO of PlanetScale, and I should use the microphone. And yes, and the co-founder of Vitess. So I have labeled this presentation "Failure is Always an Option." And I am going to run completely out of time because I got started late and I have way too much to cover. So one of the things I love about Vitess, I always say it's normally a cloud-native database. It's the first cloud-native database. And whenever you're operating in a cloud-native fashion, you have to plan for things to fail. So in a perfect world, we don't care about our machines. We don't care about their connections. What we really care about is the service. So with that, what I wanted to do is go in depth a little bit about the different ways that things with Vitess can fail and how we recover them. So just things that you already know, right? Failure is part of life. Machines go down all the time. There's two things you can do. When something fails, you can handle it, or you can just pass it on down the line for somebody else to handle it. For Vitess, we've actually put a lot of things into Vitess that handle the failures at the database level. So if you have a node go down or if you have a whole data center go down, that doesn't necessarily get propagated up to your the clients downstream. So you decided that you would like to have a cloud. All right. You've decided you would like to have a cloud-native database that can survive failure. There's a few things that you have to think about before you even begin this. The first is where you're going to place things to handle them. It doesn't matter what system you're running, right? If you have your entire database in a single placement group and a single AZ, you really can't claim it's survivable. It doesn't matter how many nodes you're writing the data to. That AZ could go down, or that top of rack switch on the placement group could go down, and your service will be down. The second thing you have to know how to do is you have to know how to recover. So we can plan for the different kinds of failures we're going to have, but then there's got to be a way to get out of it. And then the third and probably the most important thing is to know what kind of failure you can, how much risk you can accept. So things are going to fail in a lot of cases. There is going to be some kind of outage. There's going to be some kind of noticeable outside event that happens. We can go through extreme lengths to make that as small as possible and as not noticeable as possible. Or we can say we can tolerate a little bit of failure and we can have an easier deployment and a more useful system. Okay, so when we built Vitess to handle failures, what do we do? The first thing that we do is we separated the components. So in a normal database system, you have a single node. That single node has an endpoint. If it's MySQL, it's 3306. You listen to 33.0 on 3306, and when somebody connects, you serve that data, you go all the way down to disk or to remote disk to get the data and send it out. In Vitess, we actually have three-tier architecture, and since this is a deep dive, we're not going into it because I hope everybody here knows what it looks like. You can see me afterwards, I'll show you the architecture diagram. But there is a gateway process, there is a handler for the database, and then there's the database itself. By separating out these components, we can handle the failure at any single tier and be able to handle that failure at the next tier without people knowing about it. In fact, if you are using the gRPC drivers to connect to VT Gate, you actually can propagate handling that failure all the way out to your client application, and you can even survive a VT Gate going down. That's what I mean when I say push state to the edges. So we push it out to the edge with VT Gate, we push it out to the other edge with multiple MySQLs. All right, so to really show this, I've created a sample cluster for you. This sample cluster is running in two Kubernetes clusters. It is running on Google Cloud. One of them is located in US West 1. One of them is located in US East 1, which is not what that slide says, but that's where it's at. In these two Kubernetes clusters, I have two key spaces. One of them is a lookup key space, which the only thing in there is two sequences. The other is the actual database for my application. The application that we're going to demo is something that I call Goodest Doggo, or Goodest Puppers. So this is what it looks like. Here is the Goodest Doggo. If you go to pupper.planetscalelabs.com, you'll be able to play along and rate the dogs. Right now, it's not on because we're going to turn it on together. This is the application, and what we're going to show is we can lose at any point, we can lose nodes, we can lose pods, and we can lose an entire data center and still have this application work. A little bit about what's on the periphery there. We also have VTCTLD, which is our control plane, and VTGate, which was our gateway, running in both of these pods. And that URL that I told you, puppers.planetscalelabs.com, that's actually a DNS load balanced lookup between these two regions. So if you go there, theoretically, half of you will get US East and half of you will get US West. Okay, so let's talk about failure and recovery. Here are the different things that can fail and the impact it has on your system. VTCTLD can fail and absolutely nothing, no one cares, right? VTCTLD is not in the serving path, so that guy can go down and come back as much as he wants. The only thing that can't happen is you can't make cluster changes when VTCTLD goes down. So from an operational standpoint, not the best. But it's not going to stop you from serving traffic. The second thing that can go down is VT gates. VT gates are the gateway processes. That is what your application servers connect to. For this demo, I am connecting to VT gate behind two load balancers in each region. So each region has its own VT gate instances, and they are behind a load balancer, and my applications connect to that. If VT gate goes down and I'm using the MySQL protocol, clients will drop the connection. It's actually not that big of a problem because clients will reconnect, they'll come up with a different VT gate, and then they will start going, but that is the impact on losing a VT gate. Next is VT tablets. VT tablets are the wranglers for MySQL. If VT tablet goes down, the database probably should, that shard is not going to report as being active, and you're not going to be able to use it. So VT tablet and MySQL are roughly the same. It's a little bit different how we recover from them, but with VT tablet, transactions will fail, and with MySQL, you'll have to recover. Okay, so let's go take a look at where we're at right now. We have the system that I just described. This is the live VTCTLD tablet interface. I have my lookup shard, which is non-sharded. As you can see, there are some nodes in US West, some nodes in US East. And we have the doggos shard. Doggos are also in US West and US East. Two of these shards actually have masters in US West, and two of them have masters in US East. Okay? If at any point someone has questions, feel free to ask. However, we can see, for various reasons, some of them are not happy. So in VT Gate, this is the VT Gate interface for those of you who haven't seen it before. This is our view into the Vitess world. It shows us how things are going. We can see that a couple of these replicas have high replica lag. So the way that we recover from replica lag, the reason is because just before I walked in this door, I actually killed a bunch of pods. So you see all of those pods now have replica lag. What I'm going to do is I'm going to go back to VT Gate or VTCTLD. And I'm going to pick my shards that have replica lag, and I can do two things. If you're in VTCTLD, so this is going to go through a lot of the manual process of recovering clusters, by the way. So if you set up a Vitess cluster, this is what you'll get. A couple of words I'm going to say is I'm going to say hamburger a lot. These three horizontal lines, they're the hamburgers. So if you go to VTCTLD and click on the top hamburger here, you will get the pop-up that shows you all the actions you can do to recover VTCTLD. The ones that I am most concerned with are always planned reparent, emergency reparent, and externally reparented. Unfortunately, we're not going to have time to cover all of those. What I am going to do is I'm going to find one of these that has a lot of lag. So in -40, 111,001 has high lag. I'm going to go to 1,1101. And I am going to reparent the tablet. So reparent the tablet is going to reset this MySQL's replication. So reparent, and then I am going to go ahead and start slave. So what I've effectively done is I've used Vitess to go into that MySQL instance and issue the same commands that you would run if you were a DBA and you were running into it. So if I refresh this now, we can see that the replication lag has gone to 0. So let's go do it for the other ones too. 1102. Actually, I'm lazy, and I happen to have scripts. So So everything that you just saw me do at the UI is also able to be done scriptable via VTCTL client. So I've just reparented all the tablets that were not masters, and now I'm going to go ahead and start all the slaves. It's a lot easier to do it this way than to go through and try to do it manually from the UI. I did get an error, 113001. We are going to go ahead and not fix that because I'm not going to have time to. Okay, so now we can see that almost all of the errors have gone away with the exception of 13001. I am just going to keep soldiering along, though. The next thing that I want to do is I actually want to bring up the service, or I would like to load the service. So now that we have the cluster online in a healthy state, let's go ahead and load some of the SQL statements for it. So hold on a second. It's really hard to talk and type with that microphone. What I'm going to do is I am now going to provision the cluster. We have our cluster online. We want it to obviously serve our data. So I'm going to apply the vSchema for my lookup. And I'm going to apply the schema for that's the lookup table, and this is the other table, or the other key space. Okay, vSchema has been applied. For those of you who are not familiar with the vSchema, let me just walk you through it. You have the vSchema, which tells you how we're going to shard our tables. We're going to shard them by name and pupper name. They're the same value, so they will shard equally. And then I have two sequences in my lookup table. That way I can have sequential primary keys for my InnoDB tables. At this point, I have a fully working MySQL Vitess cluster. I can go ahead, I can log into it with the MySQL command line client. But first, I'm going to go ahead and grab the commands I have to run. So, again, I'm now in a sharded system here, and I am going to create the tables for my lookup, and then now I'm going to create my sharded tables, and just like that, we have sharded tables. Okay. So you can see the in VTCTLD, if you come to schema, you can now see a little bit of information about your tables and what is inside of them. All right, so we have a database. We have the database up and running. What can we do to start to harass the database? So what I'm going to do is start killing a few things. Again, this is running in Kubernetes. And what's going to happen is when I kill these pods, we're running in a persistent fashion. They have the Google persistent disks behind them. So after we kill them, they will come back up, and I can then show you how to recover from it. So, I'm sorry? It may not have. All right, so here is the results of kubectl get all. You can see that I have pods running for each of my component services. If I go and I'm on US West, Okay, so if I go ahead, I can actually kill these pods and they're going to come back up. But first, I want to show you a little bit about how they're running for survivability. Okay, so what we have is we have persistent volumes that are backing our databases, and these persistent volumes are tied to each of the pods. So if I get the pods, if I get one of the pods, we can see that the persistent volume is mounted under, interesting. The persistent volume is mounted under VT data root. VT data root is where MySQL stores all of its information. This lets me kill these pods without really worrying about them coming back up. I'm going to go ahead and switch to my other cluster. Same thing here. If I get my persistent volumes, we have all of our persistent volumes. So let's go ahead and be rash, and I am going to try to kill all the pods. And deleting all these pods, they are going to come back online. So it's going to take a second to delete. And what we'll see in VT-Gate here, VT-Gate is always your best place to look for live operational data of your cluster. In a second, what we should see is all of those pods that I have deleted start to report as not active. So they are still going down, it takes a few seconds. All right, pods are down. Okay, when pods go down, this is what we expect to see. VT-Gate is going to start reporting back that pods are offline and that it can't connect to them. If I go to VT-CTLD, I may have taken down VT-CTLD while I was at it. Like I said, it doesn't impact serving, but it gets kind of bad when you're in the middle of a demo. Okay. The demo gods are angry. All right, so we can see these pods are now coming back online. If we go back into VT-Gate, I was going to show you how they disappear out of VT-CTLD. As we go back into VT-Gate, they are going to roger back up, and they're going to report back into the cluster as healthy. Okay, so again, failure of given nodes, when you fail a specific node out of your cluster, especially in running in Kubernetes, the results are going to vary. I just deleted all of the pods, but I haven't deleted any of the nodes. Deleting a node is going to determine which services go down. When you lose a replica in Vitess, there are replicas and there are masters. When you lose a replica, the response is to do something called a planned reparent or an emergency reparent if it's an unknown loss, and that will shift your traffic from one master to another master. So if a node goes down and it's a replica node, you don't have to do anything because replicas aren't in, unless it's a semi-sync state with only one replica, you're not going to be in a place where you have cluster unavailability. If the node goes down that is holding the master, you need to then do a planned reparent or an emergency reparent, depending on if you know the node is going down or if you don't. The other thing that can go down is the entire data center can go down. So in Vitess, we have the concept of cells. You can think broadly of a cell as a failure domain. Cells can be anything from a single rack that's isolated by a top of rack switch all the way up to a multi-data center region. In this case, I have the cluster set up as 2 cells. They're set up with each one of them is spanning 3 regions or 3 availability zones in Google's cloud. So even though there's 3 different failure domains, I've set it up so that the cell concept in Vitess is all 3 of them. To accommodate for that, when we make our pods, and I will go ahead and show you, / is fine. So we use you can use the Kubernetes built-in of affinity and anti-affinity. So if I see here, this is the affinity and anti-affinity for this specific pod. And what it's going to do is it's going to ask that it is not on the same shard, it is not in the same host as somebody with the same shard, and that it's not in the same host as somebody with the same index. That prevents things like if you always set the first instance of a shard to be master, that prevents you from co-locating your master on hosts. In this case, I've set it to host name because, again, I have a multi-cell distribution. So if one of my availability zones go down, I can actually fail over all of my traffic to the other data center and not have any outages. So I can set this to host name and get a little bit more flexibility in scheduling. This takes full Kubernetes annotation support. So if you wanted to set that to availability zone, you can go ahead and do that, and it will locate your pods in different availability zones for a very survivable setup. That's really one of the things when I said you have to decide how much disruption you can tolerate as you're running Vitess. Running things in the same AZ leads to a better performing cluster. In Vitess, we by default run with something called semi-sync. Semi-sync for MySQL means your transactions won't be committed until at least one replica has received the writes. So when you think about that, if you have a multi-replica setup in a shard, that replica, when the master gets a write, it is not going to commit it until at least one of its replicas has received it. If you have those across availability zones, that means every single write transaction that you have is going to incur that latency across availability zones before it will acknowledge. That can substantially decrease performance, but it does mean that if an availability zone goes down, you're guaranteed not to lose any writes. If you put everything in the same availability zone, you get a little bit more performance off of that shard. But if one AZ goes down, then that shard, the data at that shard is at risk. In this case, we get around that because we're using Google's persistent disks. So even if the shard goes down, the data will be there when that shard comes back online. The other thing about data centers is failing over a data center is actually easier than just failing over a single node. In the event of a data center failure, we just reparent all of the nodes, all of the shards, away from that data center. If we're dealing with a single node outage, then we have to worry about what we're going to do with the individual shards that may or may not be located on that node. So we have to have a lot more operational knowledge. And again, it's easier than a single node until it isn't. And the part that it isn't is network partitions. So in all of this, one of the things I wanted to show you that I was actually just working on, couldn't get set up, was Orchestrator. If you are running a production Vitess today, you should run Orchestrator on top of it. Orchestrator takes everything that I have done and automates it. So you don't have to go through any command line utilities or any web interfaces. Orchestrator will just go ahead and fix your MySQL deployment when it breaks. Except in this case, network partitions tend to be tough. If you are all familiar with the great GitHub outage of 2018, it ended up that it happened because of a 15-minute-ish network partition. So these are always the worst kinds of failures, and unfortunately, there's not much we can do to guarantee that nothing bad happens. But network partitions can look like single nodes or they can look like entire data centers. So when we are setting recovery time periods on Orchestrator, you have to take into account the fact that a momentary loss of connectivity to your tablets may not actually be a failure. It may, in fact, be a network partition, and it's going to recover itself. The network is, in fact, not reliable, and you have to deal with that. So a lot of times what you'll see is we actually have to set the failover time for our orchestrated deployments to be a lot higher than a person would like for their applications. So something like a 5-minute or 10-minute delay of waiting and making sure something actually failed is often better than being a little bit too aggressive and failing over when you shouldn't. Because a lot of times these things aren't failures. It's things like network security policies being applied that break connectivity. Or it may just be an actual failure where somebody decides that they're going to cut fiber and you're going to be down for a week. So again, these tend to be the hardest outages to deal with. Okay, so back in business here. All of our Vitess components came back up. Let's see if they have rogered up with VT Gate. So VT Gate is now back online. And this is where we can see what is going on. So does anyone have any questions about this, about multi-cell deployments, any part of Vitess failure and Vitess recovery?
I actually wanted to, I think there's one obvious question which people may have is how are people running Vitess in production and how they've set it up. There are a few different ways in which they've configured. There's Stitch Labs, for example. They rely more on the persistent disk of Kubernetes, so they rely on the disk providing the necessary resilience. So which means that when a node goes down, they actually bring back the pod under that and tie back to the same persistent volume. The other scheme that is used by YouTube, for example, is to actually never ever recover MySQL. If a node goes down, just throw it away and build it from scratch. And how YouTube manages resilience is through the semi-sync feature that Dan talked about, is that a commit is not complete until at least one of the replicas has the data. So, which means that if you lose a node, you are guaranteed that another replica has the data, so you instantly make that the master, and then completely throw away the node, and then restore from backup, and once it is restored, point it back at the master and let it catch up. That actually has been the most popular of the configurations. Slack, for example, does use semi-sync, but they use it with a twist. What they do is they have multiple AZs, but if there is a master and a replica on the same availability zone, then the replica within that availability zone does not give you a semi-sync ACK, which means that when you commit on the master, the data has to at least be received by a replica that is not in the same availability zone. So that is another common way by which people have configured. And there are people who just play it safe. They rely both on the mounted volume and the semi-sync because they just want if your network is good, the cost of adding a semi-sync replica is actually not much, so you might as well pay the price. The trade-off for using persistent volume versus local disk is more performant because there is absolutely no latency. So if your application is latency sensitive, people prefer to do the local disk route and then not worry about data loss if a pod goes down, because you can always restore from a backup and then bring the data up. So, cool. Any questions now? We're out of time. 3:15.
Oh, okay.
Oh, is it? Yeah.
6 minutes.
Yes. Group replication is, I'm not a very big fan of group replication. I know it works, but I don't think it is really necessary because, I mean, there's so many deployments that have worked well with semi-sync replication that, and it is so much simpler and easier to manage that I know it works. I know there are some people that are using it, but I haven't felt a place where it is actually needed. I would prefer I actually proposed an alternate way of achieving the same thing that group replication does, which we'll talk about when the project moves along. Yeah. Yes. That's a good question. Like, what do customers prefer to run their instances on? Right now, there are deployments of Vitess both on Kubernetes and on on-prem, and some are running on clouds, but without Kubernetes, like AWS or GCP. The writing seems to be on the wall that everybody is moving to Kubernetes. So it's just a question of how long people are going to. There are some people who are saying that it's not going to happen. Some people are saying, we know it's eventually going to happen, so and we are preparing for it. But the good news is that if you're on Vitess, then moving to Kubernetes is pretty easy. It's pretty easy to move into that. The question is, what version of MySQL do we support? Vitess supports most modern versions of MySQL, MySQL 5.6 and up, MariaDB 10.x and up, and Percona 5.6 and up. Vitess also can run on RDS or even Aurora, if that's what you like. Yes. I didn't get the question. Can you repeat it? Oh, that's a very good question. So the question is, how do you configure sync bin log and InnoDB? Like basically, how consistent do you want your MySQL to be? So what we did at YouTube is we turned off. I don't know what the exact values of. We basically made those values extremely unsafe. Because by making those values extremely unsafe, you get a huge throughput. Your MySQL can perform really well. And the reason why we can do it is because we can throw away the node if it fails. We never recover.
So for this deployment that I have, you can set config files if you look in the Helm charts that we have on Vitess.io, or here in mine, you can inject arbitrary MySQL configs into your Vitess deployment. So in this case, I'm running with sync bin log equals 0. But again, that's you can pick how you would like to run that.
So for example, if you're running against a mounted drive and you plan to recover, then you should not be setting these values this way. It's only when you are made a decision that you will never recover a database once it has crashed. Yes. Do we have any customers of Vitess not using Orchestrator? Well, technically, YouTube does not use Orchestrator, but they have their own orchestrator. I'm trying to remember, trying to see. HubSpot uses Orchestrator, Slack uses Orchestrator. Oh, Square does not use Orchestrator, but again, they have their own version of Orchestrator. So most of these companies that have adopted YouTube, they are like real hardcore HA. They want like 5 nines of availability. And you cannot do 5 nines of availability without some kind of automated reparent. Yes. Yeah. The semi-sync configuration is actually a MySQL setting, and you actually have to set it at the database level, which means that you configure a master saying that I require at least one ACK, and you configure a replica saying that you are allowed to send an ACK. So that is how, so it is global. It is at a high level, yes.
Okay, go on.
Can you speak about performance of joins across different nodes?
So the correct answer to that is you have to group your data such that most of your queries fall within one shard. But if you cannot do that, there will always be some queries that are left out that have to go cross shards. In those cases, Vitess will do best effort to do a cross-shard join. There is a brand new feature that we have actually got a proof of concept for, which is one of the best things that I'm super excited about, which is what if you have an M by N, what if you have a many-to-many relationship? It is impossible to represent that in a sharded system. So what we are doing is we are going to do on-the-fly replication from one sharding scheme into another sharding scheme, which means that no matter which way you join, the join will always be a local join. So I presented this demo in KubeCon SF, but we had very little time to be able to cover that here, and most people are interested in how to get started with Vitess. But this feature will go into beta in about 2 months, and it's essentially an unsolved problem in the sharded world because the data can only be in one place. But now we are materializing it in different places so that your read is efficient.
So I was a bit aggressive with trying to get a high availability demo to show off in 45 minutes and cover all of the survivability aspects. But it will go up on our GitHub, on the Vitess community GitHub. So please check that out. Also, if you are interested in Vitess and would like to learn more, our Slack community is the best place to reach us. You can go to vitess.slack.com and sign up. We would be glad to go into detail about any questions you have. Like I said, look on GitHub. I'm going to put all of the files that I have for the cross data center, cross Kubernetes cluster, highly survivable cluster up on there. And I may even record a video of me actually going through it. It's probably going to take a few hours, but it's definitely going to be a good watch. Also, if you really like Vitess, PlanetScale is hiring, and you can come work on Vitess full time. So thanks everyone for your time.
Don't miss the talk tomorrow.
Oh, final shout out. Tomorrow, our friends from HubSpot are going to be giving a presentation on how they use Vitess to serve their production data. I also have it on good authority. They're going to talk about the time that they lost 17 masters and didn't have to do anything. So show up.